students, welcome back after the break. So let's again resume the session. Welcome, Dr. Rulia.
Okay, Assalamualaikum. We are back. So before starting, actually there was a question. So I just answered this question. Okay, so the question was, how do we know this data set is linear or non-linear? Basically this one actually for the workshop purpose. So that's why I didn't mention these things. So here, so if you want to know this data set is linear or non-linear, you can use the scatter plots and also apply the simple linear regression to the data set and then check the least square error. Meaning that once you check that least square error, then if that one is high accuracy, then you can say that data set is linear. Otherwise, your data set is non-linear. So previously, I have already mentioned this is only for workshop purpose. So you cannot use this data set. So this is actually for the sample. Okay, so can you share? Can you see my screen?
Yes, we can see the data screen.
Data screen, yes. Okay, so here, now we can start our second session. So basically this one actually the practical part of non-linear ARDL approach. So here you can see the data set here. So we have only 3 variables. One is carbon dioxide emission, one is GDP per capita, and this is the ANC energy consumption. Okay, so based on this data set, you see here the time period 1980 to 2019, around 40 years of data. So now we can go through our practical part using the e-views. So I will share the e-views. This is my e-views software. So I will use actually the version 9. Why version 9? Because I couldn't manage to install the latest version. So if I'm not mistaken, there is a small difference in the estimation version 9 and the latest one. Actually, most important thing is we need to understand the NARDL itself and how we can run this analysis by using the e-views, right? Okay, so this is my e-views file. So how we can input data from Excel file to e-views. So there is various options. So you can use either go to file, then you can.
Doctor, sorry for interruption. Are you sharing a screen? We don't find any screen.
Okay, you see the e-views. This one?
No, you didn't share your screen. Now we cannot see any screen.
Okay, just wait. now? Can you see the screen?
Yes, the screen appeared here.
Okay. Okay, so how we can import data except to reduce. So you can go to file. There is two options. One, either you can copy and paste, and also you can import. So I will show you the import one. This is the easiest one. Import file. Then you can open. Okay, here you just click next, then finish. So here we click no. Okay, you see here, we have data is here, and the attributes, you see constant term is here, and the range, data range is 1980 to 2019. So 40 observation, 40 years of observation. Okay. Can I stop my video? Is it okay?
Yes, yes, it's okay, no problem.
It's okay, thank you. Okay, so I can open my data set. Okay, you click this one, then Control ZDP. Okay, and then you can right click of the mouse, then open as a group. You can see our data set is here. Any missing data? No. You see, we have 40 years data. So you can name this one as a data. So, okay, so now if you, this one, we can close it and we can click this one. Okay, this is our data. So I know everyone is familiar with eViews, right? Because this is not the new software. This is the very, very old software. So everybody knows this one. Okay, so now you see, we need to check the what called the descriptive statistic. So do you remember? I have already mentioned that once we will do the descriptive statistic, we can use only the raw data or original data. So go to quick, then series statistics, sorry, group statistics and descriptive statistics. You see here common sample and individual sample. So I choose individual sample, and then here only data because I have saved this one as a data. Okay, so now okay. You see the observation here 40 years. All information is there. So whatever you need, you just take it. Okay, so here, how we can copy this one? You just click here, then Control A. And you just copy as a text. Okay, then you can paste somewhere else. Paste is okay, I can paste. I just, this one I paste it in the what file, then I will show you. So if okay, because I will show you the how do you delete okay, just lines. Okay, okay. Okay, so you can see this one. Can you see this file? What file?
Yeah, we can see what happened.
Yes.
Yes, yes.
Okay. So here, I just copy from the reviews and I just paste it here. And you see, I make it the API style. Once you want to use this one for the article, you can use the API style, and make sure once you will use, you cannot put all the digit here. Better you can use only after the point, you can use only 3 digits. This is the standard. Now, okay, so if you want to see the graphical form, so you see, okay, line and some symbol. So here, single graph, I will choose the multiple graph. Okay, so you see our data set looks like this one. You see the increasing trend and sometimes decreasing, but GDP is the increasing trend.
Sorry, doctor, your slide is stuck on the Word file.
Sorry.
Maybe you were explaining in the software, but the screen share is only the Word file.
Oh, okay, okay.
You just stop sharing this one, then again share the the views.
Okay, now you can
Yeah.
see this
We
one?
can,
Yes.
yeah, we can see.
Okay, okay. All right. Sorry. Huh? Okay, so you see here, this is our trend of the variables. How this variable, you see, our data set is 1980 to 2009. So this is our time period. So you see, this is the trend of the carbon dioxide emission. Okay, so GDP is the domestic growth. So gross domestic growth, this one is increasing, and the energy consumption also increasing trend. Okay, so now just this one. If you want to save it, you just name and save it. Otherwise, I can close it. Okay. Now I want to take the log of the data. So how we can take this log form, log transformation? There is 2 ways. So you can use like this manually.
Sorry, doctor, for the interruption. Two requests are there. One said, could you please repeat the process? And another said, how you get the figure? Please show the procedure.
Come again?
One requested, could you repeat the process? And another participant requested that how you get the figure? Please show the procedure.
Okay, okay. Okay, figure. Okay, previously, okay, go to quick, go to group statistics, then you can see here. Okay, if you want to, I will show you both. This is the, sorry, this one we didn't select. Okay, this one. You see, you can choose here the graph. Or okay, better. You can right click and then open as a group. Okay, now you can go to quick. You can go here directly, graph, or you can go here, group statistics, descriptive statistics, individual sample. You see, this is our data set. This is our variable. So you can click OK. Yes. Okay, this is our descriptive statistics. Now you can go to view, click the graph. Now you see here lot of graphs. Here I can choose the line and symbol. So here you can see as a single graph or is a multiple graph. Single graph meaning that these three variables can show one graph. So I choose multiple graphs. Then you can check OK. Then this is our graph. Is it clear?
You can proceed, Doctor. Maybe it's clear.
It's okay. Okay, now I will show you how we can take log. So here we have two options. Either is generate and another is command option. So okay, command option is like this. You can go to object, click new object. You see here lot of options. You can go series. Then you can write here, suppose carbon dioxide emission. So you can set ln CO2. Then click OK. So you see here, you have log carbon dioxide, but we need to command option here. You can see this option. So you can write here ln equal ln CO2 equal LOG log, close the bracket, then CO2, close the bracket, then enter. Now you click this one, you see this is our log variable. This is the common option. So I will show you another option. So I just delete this one. Okay, so you can go to generate. You can write here ln CO2 equal LOG bracket CO2 bracket close. Then you can click OK. You see, this is our log form. Okay, now we need to do one by one. Then again, go to generate. Then here, ln GDP equal log GDP, then close the bracket. Then you can, okay, so here we have another variable E and C. Okay, so ln E and C equal LOG bracket E and C, close the bracket. Okay, now we can check. our variable. So you see here, carbon dioxide emission, log carbon dioxide emission, log GDP, and log energy consumption. Open as a group. So you see, this is our log data, log transformation. So I can rename it. So we have log data here. Okay, we have this data set. Okay, so okay, you see here, previously I have already mentioned that descriptive statistics. After that, we will show the correlation. So this is the correlation. So this is our variable. So this is, you see, okay. Okay, this one should be 1. Then long GDP and carbon dioxide emission. This is our correlation. So here, strong correlation between these two variables. This one also. So all variables have the strong correlation. So I have already mentioned this is our not real data. This is only for the workshop purpose. So you cannot use this one. Because suppose we need to add more variables for the estimation procedure. Okay, now we check the unit tube test because we need to check either our data is stable or not. So stability. So how we can check this one? Suppose this one, carbon dioxide emission. So okay, so here you see the unit root is here, statistics, series statistics. Then go through the unit 2 and you can click here. So you can write here variable. Okay, data. Okay, I will check this one. Okay, raw data. Okay, this is our raw data because we need to check either the stationarity is level or first difference. Okay. You can see this is our CO2. Okay, you see here augmented decay. So this is our level. So we can click OK. So you see our this probability value is higher than 5% significance level. So this data is not, this is not stationary at level. So what can I do? We need to check this is stationary after first difference or not. Okay, so you can click here the first difference because you see here augmented decay test still we are there. Okay, now you can see here our data is stationary after first difference. So we can do it one by one. Now I can check Okay, if we have this data open, GDP, ENC, data input, okay, unitude, GDP, okay, so here, okay, label, augmented decryptor, label, okay, you see, our data is not stationary at label. Then again, go to view, unitude, same procedure. Then first difference. You see, after first difference, our data is stationary. Now, again, the third variable, and see. Okay. Augmented decryptor. So we just click OK. You see, our variable is not stationary at the label. Okay, now this is after first difference, our data become stationary. From this, I will show you this one. Okay. I have mentioned that we will check augmented decryptor and flip pattern. So here, if you click, there are a lot of tests. So we can use flip pattern. We see here. See, this one also not, but something is problem with the data. Okay, now we can check this one first difference. You see, after first difference, the data is stationary. So now we can proceed like this. Unit root, then we can okay. CO2, click OK, flip pattern first, then this one you can label. Okay, you see, this is not stationary. Unit root, then you click just first difference. Okay, so here after first difference, our data is stationary. Now we can go to the third variable. Okay. GDP. Now click OK. This is the label. Okay, you see, same thing. Okay, now we can go to view, then unit root, then first difference. Click OK. You see, our data is stationary. So now we can proceed because our assumption was no data, either the data is label or first difference or combination of both. Then we can use ARDL and nonlinear ARDL approach. Okay. As we see, our data is stationary at first difference, so we need to take the difference form of our data. So how we can do it? Okay, we can go to generate, then we can write here, I will, okay, CO2, CO2, I put 1 equal D CO2. Then, okay, or you can write here D CO2, no need 1. I can write 1 here just because once we will do the short run equation, short run analysis of ARDL, there is a difference form. So once we will do it, that one, the D and D. So sometimes it will just if, for my understanding, actually, I will put 1. If you want, you put here D. Okay, I will check this is the same variable, the same answer or not. Okay, check that. Okay, so here CO2 1, meaning that's first difference. Okay, then I will check generate just D CO2 like the like log, then equal D. D means difference. Then CO2 bracket close, then okay. This one, you see the same. So better I can use this one. If you want, you can use this one also. It's up to you. Okay, I can delete this. Now for the second variable, generate GDP 1 equal D GDP bracket close, then okay. Now third one, generate E and C 1 equal D bracket E and C bracket close, then okay. So you see here our the difference form, and this is our log form. So I will combine this one. So here I can take the log after difference. Okay, so here if you see log GDP, okay, this one, and I will take log. Equal. Okay, so I will take this log 0 to 1. Then okay. And so okay, so here something is missing. Okay, so which one? Difference. Loan. Okay, this one. So this is some missing value. So if I take this one, it will okay, now we have learned this one, GDP This one. So I will check generate. Okay, ln GDP 1 equal to ln GDP 1 is right to generate then ln E NC1 equal to ln E NC1. NC2 this one I can delete it. Generate ln CO2 1 equal to ln CO2 1. Now, now we can check the data. This one, ln 1, then GDP 1, and let's see. Open as a group. What's the problem? Something is missing. Okay. Just give me 2 minutes. I can delete it. Okay. Now we can check the data. Okay, this one. Select data. Where is our answer to? Try again. Then this one. Okay. Ln CO2 1 equal G ln CO2 1 bracket. Okay. Now we can check why this one is some problem. Difference. Left one. Okay. Let's check this one. Ln CO2 1 equal log CO2 1. What's the problem? Okay, never mind. I can check this one. Okay, so here, okay, later I will go to another thing. Just okay, log 5. Okay, okay, I will check it again. This one, suppose this one. Ln CO2 1 equal D ln CO2 close. Yes. Okay, now we can do one by one. Law carbon dioxide emission done. We can go to GDP, then ln GDP equal D ln GDP. Now ln GDP 1. Yes. And now next one ln EMC 1 equal D ln EMC. Bracket close. Then okay. Now we can check our data set. This one, GDP1, EMC1. Okay. Okay. You see, this is our data set now. Now we can see the estimate procedure. You see here, the first one is the variable is not here because we detrained our data. Okay. If you want to check the lag structure, so how we can check it, because previously I have mentioned that paper they use the lag structure. So here, okay, go to quick estimate bar. You can write here our variable is ln CO2 1. This is our dependent variable, and independent variable is ln GDP 1 and ln EMC 1. Then we can click OK. Now we can go to view lag structure. Then you can go to lag length criteria. This is optional actually. So we just leave it as it is because if you software select for this one, then you can click OK. So you see here all of the criteria is here. Okay, basically we can use the Akhtar information criteria or source information criteria. So here if you go to view, then lag structure, this is our polynomial graph here. You see these dots should be inside the circle. Okay. Now I just close it. Now I can proceed the ARDL model first. So you can go to view, you can go here, you can go to quick estimate equation. Then you can write all the variables here. Then you can choose here ARDL, then OK. Because we have 3 variables, so we can write, but if you have more than 5 variables or 6 variables, so this is actually quite tiring. So I can go back. So just click here, prop, then make equation. Okay, you see here automatic. This one, the equation is automatic here. So we just change here method. We can go to ARDL, auto-regressive distributed lag. Okay, now you see here option FIT information criteria, or you see here. So I just keep it here as it is specification. So if you use here, select 4 labs or in this equation or model. So I just keep it. Now you see here, just click OK. So this is our ARDL model. So you see here, lot of information here, right? So dependent variable is carbon dioxide emission. Then the method is ARDL method. So including observation 38 already here. You see now is 1982 to 2019 because we return our data. So after that you see fixed regulatory C constant. So maximum dependent length is 4, automatic selection, applied information criteria. So now selected model ARDL is 100. So what does it mean? 100. Okay, so here this one indicates that our ARDL model choose one lab of the dependent variable as the additional independent variable. And you can see here, next is 0, 0, meaning that our dependent variable, first this one independent variable, first independent variable is 0 lag. You see, no lag value. And this one also. So our GDP and energy consumption, there is no lag values. Okay. So from this model, actually you can see either there is the serial correlation or autocorrelation problem or not. How? You see, you can see this Darwin-Watson statistics. So if the Darwin-Watson statistics is greater than 1.73, meaning that there is no serial correlation at all. If this value is lower than this, meaning that there is supposed to be serial correlation problem. So now I can check the bound test. Previously I have mentioned that we need to see the long run relationship with the bound test. So now we can go to view coefficient diagnostic test. Then you can scroll down, then click bound test. You see our value is AP statistics is 8.96. So is larger than the upper bound critical value. All up. So you see, if we take 1% significance level, can. If you take 5%, can. If we take 10%, can. So it's up to you which one you can choose. So majority time actually we can use 5% significance level. So our AP statistics is higher than upper bound critical value, meaning that there is a long run relationship. So the decision criteria of the the bound test, previously I have already mentioned, but I can mention, I have mentioned again. So if the calculated AP statistics is greater than or larger than the upper bound of critical value, I1, then reject the null hypothesis. Null hypothesis is no co-integration equation. You see, no long run relationship exists. Meaning that there is a, you see, our value is this one. So meaning that there is a co-integration equation. So we conclude that there is a long run relationship to estimate the long run model, which is the TCM, error correction term. Now, if the calculated F value is lower than the lower bound critical, so critical value I0, lower bound, then do not reject the null hypothesis. You cannot reject this null hypothesis. If this, then we conclude that there is no long run relationship. Now, if the calculated F statistics falls in between the lower bound and upper bound, the estimate is inconclusive. So we have the F statistics is higher than the critical value. Or you can refer to the Narayan and Pesaran table. Then once you can write the article, you can put under this table. Now we can go to view again, then coefficient diagnostic. Then we can click the long run. Okay, you see co-integration equation. So now we can see here the long run coefficient of the GDP and the energy consumption. And you can see the probability value. You see, this probability is highly significant. And this co-integration equation bears the negative sign. This is our assumption. So we conclude that there is a long run relationship. So here I will not show you the short run relationship, because when we will do the ARDL model, same procedure. So I will show you here. Okay. Better I will go to estimate. Okay, now I can just name it ARDL. Now same thing. Okay. So here you see there is a long run relationship. GDP is significant, but there is no significant relationship on energy consumption. So if we compare these two coefficient value, which one is higher? GDP's value is higher, right? So it indicates that GDP has the dominated power to influence the carbon dioxide emission. Okay, so now here we can go to view. We can test some diagnostic tests. So here we can go to the serial correlation LM test. Okay, so what does it mean, this 2 lakhs actually here? Okay, so what does it mean? This means we try to determine whether the present value of error term is influenced by lag 1 and lag 2 of the error term itself. So we just keep it like this. So here we can click OK. Now we can see here our probability value or chi-square value is higher than 5% level. So meaning that there is no serial correlation problem. So if we have the serial correlation problem, how do we detect this? Okay, so once you have the serial correlation problem, either you can revise it or you can fail to reset the important variables. Previously, I have mentioned already, or the lag selection. So if once we do not have this problem, we can proceed, go to view, then again the residual diagnostic test, go to normality test. Our data is okay. You see here, this is our normality variable. You see that Jatabera, excuse me. Okay, so here the probability value. If the probability value is more than 5%, meaning that this data is normally distributed. So now go to view, again same thing. This is boring, right? Okay, now Krdl Statistic. Okay, now here you see lot of tests, Bruce Pagan Goodberry test, Harvey test, Glaser test, R's, Y. So I just use one because the same procedure. Okay, Bruce Pagan Goodberry test. So you can click OK. So you see our probability of chi-square and statistics value is higher than 5% level or large than 5% level. So we conclude that there is our model is free from heteroscedasticity. Now, okay. So stability test. Okay. So here, if you have this problem, so you can go to representations. So okay, I can go here. This one, our estimation. So I just copy it and go to quick estimate equation. Paste it. Now you can just click OK. Now we can go to view, stability diagnostic test, then recursive estimates OLS only. So here, cumulative sum test, then check OK. You see? Okay, so you see these two dots lines is the 5% significance level. Our criteria is this cumulative sum, this line lies between these two lines. So should be inside these two values. If inside these two lines, meaning that our model is stable. So we can go to view again. Okay, stability diagnostic, this recursive, then cumulative sum of the square test, then OK. What you see? The same result. Okay. Now I will show this one. I will show you the nonlinear ARDL models graph first, okay? Because we are here. Okay, now you see. Okay. So if you have the add-ins, okay. If not, you just for the nonlinear ARDL approach, you need to download the add-ins. You see here the EBUS file. You see there are a lot of options here: file, edit, object view. Then you see add-ins. So you just click add-ins and download. Okay, just I will show you them. Then after that we can go this one. Okay. You see this one is cumulative sum squares, and this is the cumulative sum. This is our non-linear ARDL graph. This is this blue line is within these two lines, meaning that our model is stable. So I can go back to here. So are you with me?
Yes, doctor.
Yes, ma'am. Yes, ma'am.
Okay. Just Ajana. Just I think just 2 minutes. Huh? Once Ajana is finished, then I will start again. Okay. So any question until this? The ARDL approach? Any question regarding the ARDL model? Because now we can proceed the nonlinear ARDL approach. Any question? Okay, so fine. Okay, so I can proceed the nonlinear.
I have a question to ask. I just want to know that gender causality test is necessary to test in the ARDL model. Is it necessary gender causality test to do?
Actually, this is the step, but for the article or for the research, you need to do it.
Okay, doctor.
This is the only the ARDL model you cannot rely because you just need more justification.
Okay, so it's just an option. If I want, and then I can do, or otherwise not.
Yes,
In ARDL model.
yes, but better you can use. Then you have strong justification. You need to any other model you need to do the strong justification.
Okay, thank you, doctor.
Okay, welcome. So any other question? If not, then I can proceed the ARDL process. Okay. Okay. So here, this is my old version 9. So I think latest version you have already add-ins. So if you do not have add-ins, you just go through here, click add-ins, then download add-ins and nonlinear, then you can click OK. Because I have already here, you see download add-ins, so no need. So I think everybody has this option, right? Okay, I can proceed. Okay, so for the nonlinear ARDL approach, of the extension of ARDL approach, I have already mentioned. So here, how we can do it? I have add-ins. I just go to view. I can go to label. Then I can write here ASYVARS. Asymmetric meaning that asymmetric. So, okay, asymmetric variables. So I have 3 variables only. One is dependent, another 2 is independent. So I can write here ln GDP1 space ln ENC1. Okay, now we can enter. Now go to add-ins. Then I scroll down, next nonlinear ARDL. Just click. You see here, I have the equation here. You see the variable automatic here, positive and negative shocks. You see, if you see the EBUs, automatically set their equation or variables. Okay, so here now, okay, I can go to view. Long run estimation. Okay, you see here this co-integration equation, and this one is the significant value. Previously, I have mentioned the ARDL and NARDL approach quite similar or same. So here we have only add this variable, right? Positive and negative value. But in the ARDL model, there is no positive shocks or negative shocks. So here we have the long run estimation here. This is the positive shocks and negative shocks of GDP. There is a significant influence on the carbon dioxide emission and the energy consumption. The positive shocks, there is a significant relationship. Either the negative, there is also the significance relationship. So here, actually, I will show you the short run estimation of that model, because if I show you both in the ARDL, and NARDL, this is actually it's time consuming, and this is actually tiring part. If you write the wrong equation, the estimate cannot be accurate. So here, okay, I can copy this one. Copy, okay, copy as displayed. I just click OK. Then I can okay, go to generate. Here, you click here, generate. I just paste here. This one, paste. Okay, now I just rearrange this one. Okay. Okay, now I just rename this one ECM. Now click OK. Okay, you see here, this is our ECM. Okay, why this one is 2 lakhs, not 1 lakhs? Because we retrain the data once, and once this one, because ECM is the criteria is lag 1 period. So once we detrain, and another one is the lag period. Okay, so here now okay, so here we have new variable, right? I have already mentioned there the ECM, our new variable we created. Okay, so we can create another variable like, okay, so here you see we can follow this one. all this one, then we can estimate the model again. So how we can go? Just we can go through the again generate. Okay, so our variable is, you can check D loan GDP 1. I just write underscore, sorry, 1 underscore, then positive value equal loan GDP 1 underscore positive minus loan GDP 1 underscore positive bracket close length 1. Now click OK. So this is our second variable as in the short run equation. So now we can write one by one. So that's why it will take time. So now we can go again generate. Second one, D loan GDP 1 underscore negative, because previously I wrote the positive shocks. This is negative equal loan GDP 1 underscore negative, okay, negative sign, then loan GDP, okay, underscore NEG, then leg 1 period. Okay, now close the bracket, then okay. Sorry, I think you see this one is not defined, meaning that okay. NEG, loan GDP, loan GDP 1 negative, loan GDP 1 negative, then loan GDP off. You see? Oh, okay, 1. You see, if I, okay, now I think, okay, yes, okay. Now again, now generate this one, just the GDP positive and negative shocks. Now we have two more because of the energy consumption. So we can write D loan and C energy consumption 1 underscore same thing, positive equal, okay, loan E and C 1. So better you can just copy and paste, then you can change the variable name. This is easy, huh? Otherwise it will take time. Okay, so 1 underscore positive, then negative loan E and C 1 underscore positive, then leg 1. Okay, now okay, now last one. Last one is for the negative one. Okay, so D loan E and C 1 underscore negative equal loan E and C 1 underscore negative, now negative sign, ln E and C 1, okay, underscore negative left 1. Now close the bracket, then I think okay. Okay, again, okay. Here, okay. 1 negative equal MC 1, I can recheck negative, okay, you see this one supposed to be ln ANC 1, I think, okay, you see. Now we can go to quick, then estimate equation. Okay, now you can write this all here. Okay, I can write, then I can explain. Okay, ln CO2, because this is our dependent variable, so this is constant term, and I can write all these things. Then D ln GDP 1 underscore positive okay, positive, then D ln GDP 1 underscore negative ln, sorry, D ln GDP 1 underscore positive. This one is very critical. You must write carefully. Now D ln GDP 1 underscore positive 2, because our estimation there is the positive 2 and the positive 3. That one from the equation, so we can follow the equation, follow the estimate actually, the short run. So D ln GDP 1 underscore positive negative 3. Okay. Okay, so better I can copy these things, then I can just change the name. Otherwise it will take longer time. This here, so I can mark it. Okay. So here E and C, we just here ln E and C positive. Okay. We just change the variable name. Ln E and C negative 1 negative okay. So here okay, negative okay, you see here E and C, this one not positive, huh? You see the equation, this is negative M and C. one G, B, C, so we can change B and C. Negative. N is B. Okay. B and C. This one negative. N is G. 3. Again. PCT. Sorry, we can remove PCM. PCL minus 1 if you write PCT, then you can, because this is from here, our same equation. Okay. Make sure you can reset. Later I can copy first. Otherwise, okay, I can copy. You can copy and keep it somewhere. Okay, now you can reset. So I can write in the same form or not. We just recheck this one. Okay, now you can. Okay, click OK. Bismillah. Oh, you see, it's not defined. Then something is missing. I can try. Okay, so here, long CO2, T, BIM, GDP 1, positive, GDP 1, okay, negative, GDP 1, positive, okay, one shot, then GDP 1 underscore, positive 2, GDP 1 underscore, positive, okay, negative 3, okay, so that's the problem. Okay, so D, long, E and C.
This one, D is ENC1 positive. This one, I think you don't put LN, DLN, right?
Oh, okay, just, yes, yes.
Yeah, LN.
Yes, thank you. That's why I asked this one actually. Okay, sorry. DLN. Right. Am I right? DLN. I think DLN UNC1 positive. Okay, sorry, DLN. I think okay, positive. DLN UNC1 positive. Then BNC 1 negative. Okay, okay. Negative 1, negative 2, and negative 3. Okay, so any chance, anything wrong here? No. Okay, just I can click OK. Yes, thank you so much. Okay, so here you see this is our result. Okay, you see here. You see that ECM or ECT, because I mentioned here ECM, that's why I put here ECM, error correction model, or if you say ECT, error correction term, same thing. So here you see this one is negative and you see lower than 5% probability value. So this negative sign, that the model, you see this negative sign indicate that the model moved back into the long run when the short-run shocks occur in our estimation. You see here, in this case, our value is this one, 0.686. So this is actually important. And some of the articles you can see, they can explain this one. Okay, so it means that any shocks happen that in the independent variable, our independent variable is carbon dioxide emission. So it will be corrected based on the rate of 68% per period. And it will take how many years? How do you calculate? You just calculate 1 over this value. You just ignore this negative sign. You just 1 over this value. So this is actually roughly 1.45, right? 457 or 46, you can say like that. So roughly 1.46 period for the model to move back into the long run equation. So that is what error term ECT or ECM represents. So it shows that actually the speed of adjustment or period of time. When short-run shocks occurs and this equilibrium happen in this equilibrium, will move back into the long-run relationship by the rate of 68%. Since we are using the yearly data, so it will be corrected 68% in a year or per year, and it will take 1.46 years for the model to move back in the long run or the long run relationship. So after 1.47 years, we can go back to the equilibrium position for long run relationship. So here, okay, same procedure we all have already mentioned here. So now we just check this one, and after that you see here, this one positive is 1 value. So you need to check if you have more than 1 coefficient here. So you don't know which one is significantly influenced or not. So what should we do here? We need to check the wall test. It's okay. Some of the articles actually I have mentioned. I will not show you, but okay, I will try to show you the wall test here, because once you see here GDP positive. So GDP positive 1 value. So actually in the short run, so no need to explain, go to the Y test because only 1 value. If you test the Y test here for 1 value, the same result. So here we have 3. So you see, you can see here, this is C1, C2, C3, C4, C5, C6. Then one by one, 7, 8, 9, 10, 11. Okay, so here C1, C2, C3, so C4, 5, 6. So how do we check wall test? So you can go to view, go to coefficient diagnostic test, then go to wall test coefficient. Okay, sorry, I can go back. So here 1, okay. You see, negative 1, only 1. So sorry, positive 1, we have this one, positive 1, positive 1 shocks, 2 shocks, 3 shocks. So we need to check this one, C2, C4, C5, and C6. These 4 equal 0 or not. So go to view, coefficient diagnostic, then go to wall test. Then you can write here C, okay, bracket close, 2, okay, equal C4, C4 equal C5 equal C6. equal 0. So now we can check. And you see, jointly, we see here, there is no statistically significant, meaning that in the short run, there is no statistically significant the GDP on carbon dioxide emission. So same thing for the another variable here. You see this one positive negative. So here negative positive 1, I think no need because we have 1, but here negative 1 individually. If we check, if you not check, okay, but you see here negative 1, you see this is statistically significant only. Okay, this is not lag period, lag 2 period and 3 period, lag 2 and 3, there is a significant influence, but jointly there is, I think, no statistically significant on carbon dioxide emission. So I can check jointly because this is the individually, if you explain. So here, this one, okay, sorry. Oh, not this one. What is that? Okay, so now we have C1, C2, 3, 4, 5, 6. Okay, 6 done, 7. Okay, now 8, 9, 10, 11. 8, 9, 10, 11. So go to view. Same thing. Okay. C8 equal 9 equal 10 equal C11 equal 0. So jointly they are significant or not? You see, jointly they are not significant, not influencing, but individually they are influencing. So I think that's all for my side, because long discussion, it's too difficult to conduct the long discussion. 3 hours. Okay.
Yes, doctor, and this calculation also not so easy to remember. Alhamdulillah, you did it step by step in depth analysis.
Okay.
So it should be very helpful for our participants. So I don't know if the answer is already given. Some question is in the chat box.
Okay.
If already answered, then skip the question. One is from Brother Umar Farooq. He said, ma'am, is there any alternative to check out the stability of ARDL coefficients if the cumulative sum graph gets out the critical bound red lines?
Okay.
Is it already answered?
This is actually the bound test. For the bound test, the co-integration of long run, you can use either 2 ways, either the bound test, or you can refer to the error correction term, ECM term. That one I have mentioned, because if our bound test value, estimated bound test value is higher than the upper bound test, then you can say that there is a long run relationship. Okay, this is one option. If you not like to take this one, you can use the error correction term. This one should be negative sign and the statistically significant. If you have fulfill these two conditions, so you can say that there is a long run relationship, either one, or you can mention two, no problem. Because if you use two, this is the strong justification.
Okay, and thank you for the answer. And I think Dr. Rafi already answered some of the questions here. So if the last question was, while estimating the short-term coefficient, putting lag structure automatic, we are unable to get coefficient of most of the variables. Doing away with the problem, I am putting lag of dependent and independent variable fixed so that I could all coefficients. To test symmetry and asymmetry by using all test, how far the procedure is correct? Can we proceed in that way?
Oh, okay, because this one, once we, okay, this is this is the old version 9, Hebrew software 9. If you have advanced level, if you have 11, the latest one, 11 or 12, so automatically this one you can set that one, or you can the wall test. So where is this one? Okay, I can. Okay, so here, estimate. Your question is here, like variables. Am I right?
Yes, ma'am.
Okay, if you, okay, you see here, this one actually I put from where? Once I go to the estimation, that one, the short-run equation, from there I create the new variable and I put the lag, and whatever there, I didn't put with myself because I saw there they automatically mention lag 1, lag 2, and lag 3. That's why here I put. And once you click here, you see this one. This once I have created the variable and estimate, this one is automatically here.
Hello, ma'am.
Yes.
Ma'am, actually, when I am estimating this short run in NARDL, when I put automatic lag, I'm not getting most of the variables there. The screen you share, I'm not getting like this pattern type variables. Some of the variables are taken by the system as perhaps honestly maybe non-statistically non-significant, insignificant. But once I am putting the lag fixed, then the system gives all the variables.
Sorry, you can ask me question again because I was in problem. My son was come and cry, so just
Okay.
okay.
When I'm calculating short-run coefficients or error correction coefficients using NARDL model, first step I'm putting the lag of the dependent variable and independent variable automatic. I'm putting lag 2 for dependent variable and lag 2 for independent variable. Sorry, I'm putting in this. I'm taking the lag as automatic, but result is some of the variables. System does not give me results for some of the variables. But when
version you can use?
Yes.
So I can use the EBUS 9. So which one is yours? 9?
Yes, ma'am.
You have also used the 9, right? EBUS 9.
I'm using EBUS 12.
Okay, so okay, that's why this is the problem, I think, because this is the advanced one. This is the latest one. There is some of the option
Update.
automatic
Yes,
there. Okay.
Oh, yes, ma'am. Yes.
I just did here manually something. You see, I ask you, you must need add-ins. You must download.
Sure.
But in the, I think the latest one, no need to download it. There is automatic this one, right?
Exactly, ma'am.
That's why the problem. Okay, if you have any problem, then you just ask our moderator. Then you can email me or WhatsApp me. Then I can try to solve.
Okay, ma'am. Thank you, ma'am. Thank you. Thank you.
I just want to add here, like when you are doing an ARDL, right? So maybe in the when you estimate the equation, okay, there is so then beside this on the right side you have option, right? So maybe in the option you click, if you use the method is unidirectional. Hear me?
Yes, ma'am. Yes. Okay.
And then the insignificant variable automatically they delete.
They automatically, but ma'am, when I have to this estimate wall test now for short run or long run asymmetry, in that time I must have the coefficients of those short run variables, short run coefficients on those variables to test the wall test. But once that system takes those as parsimoniously insignificant and does not resemble those on the screen, I am unable to conduct wall test in that.
Okay. So in that case, maybe just now you mentioned that you have to fix the lag. Then maybe you can get the.
I'm resolving the issue by putting lag fixed. And my question was, is it justifiable?
But
Can I
then
do this?
did you use the selection criteria for like lag selection, optimum lag?
Yes, ma'am. I'm putting a KENMS information criteria.
Don't use the automatic one. You use the optimum lag selection criteria. Then you get the optimum lag, right? Using that SIC or AIC, you can get the optimum lag selection, right? There.
Actually, ma'am, when I'm putting, hello, ma'am.
Yes.
When I'm putting a KENMS information criteria and on the another side I'm putting lag automatic, then I'm saying the system that you have to choose the optimal lag from 0
you
to
have
4.
To choose the optimum lag.
You have to choose the
yeah.
But the thing is that when the results come out, the lag of independent variables, I'm getting lag of independent variables. I'm getting 1 0 0 0, something like this. Those variables on which I'm getting results at 0 lag, matlab at level. Or getting my.
Maybe this is by default, right? Like something like. Okay, then maybe you can do just how you mentioned. You fix the lag and you run it.
Yes, okay.
This is the lag selection criteria. You can either use SC, not AIC, yes. SC, because sometimes you change that the lag selection criteria, these are the different result.
Yeah, yes.
If you have the mushroom 12, this is actually quite financial.
Okay, ma'am. Thank you, ma'am. Thank you.
Any other things? If you have any problems, then you can discuss later on. You can either email or WhatsApp, then you can discuss.
Inshallah. Thank you, ma'am.
I think we are already end of the session. Okay, so I would like to express our thanks to Dr. Rulia, okay, for joining this session and giving his lecture on this nonlinear ARDL model. So actually we are all in the learning process. So I think that she can give input to your already give input to your learning process. So her lecture today, I hope that it will bring benefit for all of you who are doing this nonlinear ARDL model, or maybe you can if you can do in your research master's or PhD level. So because of the shortage of time, that maybe she cannot go detail, because 3 hours I think is not enough. Okay. So that's why we need more time, but maybe later in the next series we will give more time for the speakers as they can go detail. So tomorrow we have a session, but there is maybe some little of changes because one of the speakers have some problem. Brother Muhibullah will announce or confirm the tomorrow's session. So please look at that one. If there is changes, please cope up with that one. And after that also, I am inviting, for tomorrow's session. But please look at your email if there is any changes. Okay. So Brother Muhibullah, please end the session with.
Thank you, madam. Thank
Okay.
you. Alhamdulillah.
Yeah. Thank you, Rulia, Dr. Rulia. Basically, she is my student, PhD student. She did PhD with me.
Master's students.
So inshallah, please pray for her as she can, go further. Okay. So thank you, Rulia, again.
Okay, thanks.
And okay, Brother Muhibullah, please. Brother Muhibullah, we cannot hear you. Please unmute.
Cannot hear. I think.
Oh, sorry. I was muted. So thank you, Madam Rafia and Dr. Rulia, for the nice session. I hope it will help us a lot as it was almost in details, and for those who attended, maybe sometimes they can miss some issues and need to recheck. So as we have Facebook live session, they are already recorded. So for now, you can check that one to again to know the steps. And for tomorrow's session, as Dr. Rafia already informed, so as there is a limited participant, so we will announce it through email. But for now, I want to inform that our second presenter of tomorrow's session, the afternoon session, Dr. Nazima Illahi from Pakistan. Her mother is affected by corona, maybe in critical situation. So we might not continue that session for tomorrow. So we pray for her mother's early recovery and give patience to them so that they can manage the situation. So for today, we already have taken a long time. Inshallah, we can meet in the tomorrow morning session. And for today, I would like to finish the session here. So before this, let's recite Surah Al-As and finish the session. Okay, thank you everyone again. See you soon, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.
Very much.
Assalamu alaikum.
Brother Muhibullah.
Yes, please.
Okay, thanks again.
Take care, doctor.